Hello, everyone. I would like to introduce myself. I'm an associate data consultant in Lithium, and let's get started. In essence, Azure Data Factory was designed to solve data integration challenges. It arises from the fact that data sources are becoming more and more distributed and fragmented than ever before, and data growing exponentially in volume. And in this respect, raw data accumulated in diverse storage systems, for example, Xero, relational data, or local Excel files, lacks the correlating context by itself, which is so necessary to conduct any cross-analysis or employ BI tools to build reports over existing data. That's where data integration takes place as a process of combining data from various sources into one unified view to derive meaningful insights. And however, data integration systems such as Data Factory or another example is Matillion do not just allow for data integration as it might seem at first sight. Most importantly, they can trigger the batch movement of data by following a regular schedule, which is often referred to as orchestration. And at the same time, they have native functionality to ingest and transform data, or sometimes instruct other services to perform the actual work required on its behalf. For example, there is a Databricks service to do any transformation task. Can we go to the next slide, please? And to conclude it all, we can say that ADF is or Azure Data Factory is a cloud-based data integration service that orchestrates data movement and transformation between diverse data sources and cloud compute resources. So it's the definition from the documentation. However, how does it work? At a high level, it has a set of interconnected systems that give an end-to-end platform to perform all data engineering tasks. Though both ETL and ELT integration patterns can be hand-coded, and it's easy to use the Azure Compute service, there is a user interface-based, code-free and friendly functionality which covers 5 main aspects which you might see on the slide. The first is ingesting the data, and it's very easy to do with more than 100 native connectors for various systems, and you don't need to write a single line of code. Next, regarding the control flow, you need to create a data pipeline in Azure Data Factory, and later I will show you how to do it. And in this data flow, you can use any types of workflow constructions, such as loops or conditional execution or parameters or variables, and etc. Then subsequent step is data transformation or data flow. As I've pointed out before, it can be sent to some other service, which is Databricks. And another good example is just to use the data flow component from Azure Data Factory, as it helps to achieve all the same tasks as Databricks do. And concerning the scheduling and monitoring, probably it's one of the most important functionalities which are provided by Azure Data Factory, because you never know how successfully your data transfer went, or whether there is a specific event that should trigger a job. And both user interface environments provide for scheduling and monitoring. And to see Azure Data Factory components in operation, let's switch to the demo part of this webinar. We can go to the next slide. The case I'm going to demonstrate refers to accounting data accumulated in Xero system. And though Xero is perfect for supporting all accounting activities, it doesn't provide enough BI tooling to grasp some data insights. And in that sense, Data Factory can help us build the database, and Power BI can help us get some insights we're interested in. So let me show you the interface of Azure Data Factory first. This is a welcome window, and actually you can see here all of the kinds of the resources that you might have implemented before. But how do we start working with Azure Data Factory? The first thing we need to do is to create a linked service connection. A linked service connection in itself is some kind of a connector that we would like to use to access our data. However, it's not yet the exact object that we would like to connect. So how do we create it? We use the Manage button on the left-hand side panel. We use linked services, and we click on New Service. And here we can search for the connector that we can use for our purposes. But I would like to say that for any resource, you can use the API REST connector. But of course, it's much easier when there is an already native connector installed. And let's choose Xero here. And the first thing that we need to do is to give it a good name. In my case, I can use just the Xero name. It wasn't yet employed in the data factory. Concerning integration runtime, it's something which is installed when you are setting up your data factory. So I'm just going to use the integration runtime, which was pre-installed. And the next field is authentication type. I'm going to use this authentication type because Xero application for authentication supports it. Next thing we need to do is to enter credentials for this linked service, and the host will be as simple as that, api.xero.com. For the client ID, we only need to copy from already known application. So it's a client ID and the client secret. The tenant ID is also known. It's not changeable data. Meanwhile, I need to note that when we create a connection to Xero, there is a certain limitation regarding the usage of tokens, because as you can see, we simply use the only manually entered token. If we want it to be updated, and if we don't want to be dependent from this manual action, we would like to employ some other technology like REST API. There is an option to test our connection, and we will do it to make sure that everything is set up correctly. So connection is successful, so we can just use this connection for all other activities. The next step will be to create a pipeline. And what is essentially a pipeline? A pipeline is, in its nature, some set of activities that we want to complete as one single step of data transformation and data movement and transformation. So on the author tab, what we need to do is to create a pipeline. You might note that we can create the pipeline from a template, but we're not going to do it. But there are some very common data transformation technologies there, and you can use the ready-made template. I think that it's a good idea always to give some good logical name to any pipeline, to any object in ADF, so that you know what is the task for each object. And in our case, it will be get Xero data. And I think that the first purpose for this pipeline will be simply to copy data from the Xero database to our Azure SQL database. As you can see, the copy data activity, which we are going to use, contains a lot of configurations, but we are not going to talk about all of them. I will just configure some of the most essential ones. The source data set. This is the data set which will be a Xero data set. I should say that again, we need to name it in some good way, like for example, Xero source and invoices, because we are going to do the invoices. Linked service will be Xero, simple Xero, and the table name. We need a couple of seconds to wait until the table names are retrieved from the Xero databases. And the one we are interested in right now is the invoices table. So we click OK, and our source is created. The next step is to create the sync table. And we already have our Azure SQL database configured, so I'm just going to refer to it and create a table. It will be, for example, Xero invoices. The link service will be Azure SQL Database. As I told, it is already configured, and it's done in the same way as we did with Xero. And right now, we don't have a data table in our database for this connection, so we are just going to enter it manually. First, there is a name of the schema, and then we're going to say that we want to create the Xero invoices table. And import schema is none. So we are done at this stage with creating the data sets. Now, however, there is one more option we need to indicate. It's a table option, auto create table, because we don't have currently such table in our database. And finally, the mapping. The mapping is the table which shows us what will be the final columns that we are going to have in the database. And we also will have a look at the types of data associated with the columns. And you can see that sometimes they are defined in the correct way. For example, for updated date UTC, there is a date time type. However, for some numerical data, there is a string type, and we are going to fix it a little bit later. This is the first object. It will be copy invoices. However, to build a report, we will need another object. Let's say it's an object called copy payments. The source table will be created in the same way. Need to wait a little bit for the table names to be retrieved. And we are going to find the payments object here. And press OK. And we do the sync as well. Again, will not forget to indicate table option auto create table and import schemas for mapping. And that's it. We have the schema according to which the data will be copied into the database. So right now it's a time to test how it actually can be executed. So we can run all the jobs in a debug mode. However, as I already mentioned before, we can schedule these jobs. But right now we'll simply debug both of these. As you can see, there is a output tab where you can look at the progress of copying. And when the copying is completed, you can as well look at the details of your copy. Like, for example, we know that 87 rows were copied to our database from the invoices table. And 85 rows from the payments table. All right, we can publish our work right now so that it's not lost and we can use it later. By the way, at this point, I can say that we can integrate GitHub and another systems for saving the versions of our code. Because again, we're now using the user interface environment, so it's a wizard way to do the copying of the data and all other tasks. However, sometimes it's even easier for you to create code for this copy data activities. Okay, but right now, what we are going to do next is a transformation job. As you remember, in the invoices table, we have saved the data in some incorrect formats, and it's better to save them in our database in the correct format so that we can skip the data transformation in Power BI. How it can be done? Firstly, we can create a data flow. There is a new data flow button, and since we're going to do the data flow debug finally, we need to create a special cluster, compute cluster, to do such a debug. Meanwhile, we need to first add the source, and as a source, I will indicate a table which we have already created in our database. So it will be Xero DB invoices. Since our cluster is ready, we can do the projection once again to make sure that all of the data types are indicated correctly. Just take some time. Yeah, so we can see there are 25 columns with the types. The transformation we're interested in is the derived column. And we are just going to select a few columns which are important for our reports, which are going to be important for our report in Power BI. It will be the total column. And we should write an expression which converts our string data into the numeric format. For example, it can be functional to decimal. There are many arguments, but only the first one is necessary. Others are optional. So we can use the total column from schema, save and finish. And finally, as we did this transformation, we can sync it to some other source. I will suggest to create another table in our SQL database, just to make sure that the data will be written in the correct format in another table. So we will create a new table, schema name, and Xero. And it's good to check on the settings tab that we have other options indicated correctly. For example, for us, the relevant one will be recreating the table, as we again don't have it currently in our database. And that's all that we could do for this data flow. Of course, you can do the data preview. However, in order to save some time, we will not do it currently. And how do we actually run this data flow? This data flow can be already implemented in the existing data pipeline. So I will simply drag and drop my pipe flow. And actually, I can connect it to these two blocks, but I'm going to stop debug only at this point because I don't need to recopy all the data. They are already stored in the database. So I'm just going to debug this data flow and see whether the table appears in the database. So we're using the data flow debug session. Sometimes it needs to be updated more frequently. Yeah, it's running. Yeah, it's finished. And we can also see the progress. We can see that 87 rows, the same amount as in the initial table, was written into the database. Okay, and that's all about the data factory part of our webinar. And I'm just going to quickly show you how to create a Power BI report. When you have your desktop application opened, you simply need to click on the Get Data button. And from the Azure sources, we just need to indicate Azure SQL Database. And we only need to enter the server name. We don't even need to enter the database name. It's optional. We can select it later. And here it is. If you remember, we were interested in a couple of tables, which are Xero invoices and Xero invoices processed, and also Xero payments, but not this one, probably this one. Yeah. And we simply load them. We don't need to transform the data as it has already been done in the data factory. Great. So the data has been loaded. We can have a look at them in the table view. And as you can see in the Xero invoices processed table, just in the very end, the total column will have the general type. and actually it can be converted to it's a numeric type in its essence. However, the closest column tags is still in the character type, as we haven't transformed it. So what is the good practice when we are working with Power BI reports? The good practice is to check the relationships between the tables. Well, we are not interested in the table Xero invoices, by the way. We just kept it to be able to compare the data types. However, both tables Xero payments and Xero invoices can be connected to each other with a single field, which is invoice ID. Why do we need to create such relationships? Because later when we create a Power BI report, it's easy to apply different filters and they will be responsive on both tables. And finally, I will just quickly show you how to build a couple of nice visuals. So the first visual that might be interesting for anybody will be the stack column chart, and I'm just going to drop some interesting numeric data here. For example, the y-axis will be the total amount, and the x-axis will be the due date, and the legend will be the status. So yes, and as you can see, there are many unuseful statuses for us, and we can, by the way, drop them from the list. And yeah, and by the way, we haven't yet figured out that in this table, there are different types of invoices which are analyzed, and it's not correct because we are mixing accounts payable and accounts receivable. So we're just going to use a single filter for accounts payable, and we can drop several statuses which are not relevant for us, but both are relevant actually, authorized and paid. Yeah, but probably if we choose some other type, which is accounts receivable, the statuses can be different. Yeah, for example, the page will be the correct one and authorized, but the drafts are not interesting for us. So what can we do with this data? We can drill down into the quarters or into the separate days. However, it's not very convenient to look at this data. That is why I always recommend to create some nice slicers. And for example, we can create a slicer for the due date, and we can filter the date, filter interesting date for us. And probably just a couple of more visuals. It's a tree map, and we can again analyze the amounts split it by our counterparties. I think it will be the category. And at the same time, we can create, for example, some table where we drop the contact name from the invoices. We can also use the invoice ID, or not the invoice ID, but it's better to use the invoice number. It's more informative for us. And from the payments table, we can select several columns, for example, or actually only one column, which is payment date. And you can see when each invoice has been paid or whether it was paid. But in this table, the data has been filtered to include only the paid invoices. So this is a very simple dashboard, and probably in its final state, it can look like this. This is the invoices payable table, and as you can see, the design is a little bit different. I've applied some other grouping, and in order to create the same dashboard, but for the other category, for invoices receivable, you simply duplicate this page and choose another type like accounts receivable, and it just rebuilds for another data type. And that's it, I think, from the point of the webinar. And I'm happy to answer any questions. I know that we have run a little bit out of time, but still, if you want to ask anything, please do.